Hello, and welcome to our last lesson in the factoring unit. We are going to be combining lesson 4 and lesson 5 into one lesson, because lesson 5 is basically just a quick summary. After that, I'm going to assign you some homework from this assignment here, which you will hopefully complete and post a link. Type your answers out, or you can put an image if that's possible. I don't know if an image is possible on YouTube. If not, you can I'll put a link to my email in the description below, and you can email it to me. So before we begin in earnest, we are going to first complete lesson 4, which is factoring differences of squares. Now, this is something that trips people up even if they get to grade 11. This is one of probably the easiest factoring you will do. But it's also actually some of the hardest to spot, because it's not it's one of the easiest to spot, but most people just miss it in the end. You shouldn't, and hopefully the fact that I'm mumbling away right now conveys my deepest and sincerest hope that you will not make a mistake on this kind of factoring. But a difference of squares is a special type of quadratic where the b value is 0. So again, the name says it. You have a difference of squares. That means you have a subtraction in the middle, and then you have two square terms. Like you see here that we have an x squared and a 36, which is a perfect square. So that is a difference of squares, because we have a square, and a subtraction sign. Difference of squares right there. But the idea here is that why it's easy to spot when I'm asking you to factor this is, as previous, we've been doing all trinomials. We did simple trinomials, with factoring, we did tricky trinomials. We even did one question where there was tricky trinomial with factoring. But here, all of those were trinomials. These are binomials, because the b value is 0. We had like an ax squared plus bx, but since b was 0, that was plus 0x plus c. This is just ax squared plus c. Not plus c, minus c, because it's a difference. And that's what my term is going to look like. So whenever you see a binomial, two terms with a subtraction in between them, automatically you should think difference of squares. And factoring a difference of squares is actually super easy, because we'll see here that, let's look at this x plus 5x minus 5. You have an x squared minus 5x plus 5x minus 25. And when I combine like terms, minus 5 plus 5 gives me 0. My b value becomes 0, which is why I end up with this x squared minus 25 binomial, which looks like a difference of squares. Now I want to know how to go back to here. And as you can see, this is fairly straightforward, because the numbers, this is the same as this, and not the plus, the 5 and the 5 are the same. And you know what the two brackets, you're always going to set it up just like our simple trinomial. You're going to set up two brackets, and it's just a matter of finding what numbers go in. And hopefully we can see that we got the 5 by doing the square root of 25. And more on this in a moment. But again, if we expand here, we'll see that we get the same idea. X squared plus 2xy minus 2xy minus 4y squared. These two they become 0xy when you collect like terms. I'm left with x squared minus 4y squared. And here again, you'll see that x, 2y, 2y, and x was the square root of x squared. 2y was the square root of 4y squared. And I have 1 minus and 1 plus. 1 plus and 1 minus kind of deal. So let's try and factor the difference of squares in a similar fashion. Again, there's not much of a rule here, and there's not really, you just have to know how to factor a difference of squares, which is why identifying when there is a difference of squares is super important. You see a binomial, there's a subtraction sign there. This is a difference of squares, especially when you have two perfect squares. So what you're going to do is you're going to set up two brackets, and you're going to take the square root of the first one, which is an x. You're going to take the square root of the second one, which is a 6. You're going to do x plus 6, x minus 6. And this, if you expand and check, you will get x squared minus 36. Again, it's quite, hopefully we can see it's quite straightforward. Two brackets. Again, I see it's a binomial, two terms, subtraction sign in between them. Both have square-looking thingies. I say difference of squares. I call difference of squares. Take the square root of the first term of the entire thing. So square root of 9 is 3. Square root of x squared is x. Take the square root of the second one. Square root of 25 is 5. Square root of y squared is y. Put a plus 3x minus 5y. This is my factored form. There. Again, let's try another one. Difference of squares, binomial with the subtraction in between. Square root of this is 10. Square root of this is x plus minus. Difference of squares, boom. Again, you'll see here that hopefully that this is not a lot of complicated stuff. It's fairly straightforward what we're doing here. So you'll just have to be careful while taking the square root of stuff. So square root of x squared is x, and we'll get to some more complicated-ish square roots. But again, I see here two terms, subtraction sign in the middle, difference of squares. Square root of this, 4xy. Square root of 16 is 4. Square root of x squared is x. Square root of y squared is y. Square root of 49z squared, 7z. Square root of 49 is 7. Square root of 7. So once I take the square root, I'm just going to put a plus and a minus. It doesn't matter which order you put. You can put plus here, minus here, or minus plus. It doesn't, makes no difference. Okay, let's proceed with difference of squares. Just kidding. This is not a difference of squares. This is a binomial, but this is an addition of squares, and therefore this cannot be simplified any further. There's no formula for addition of squares. There's no two brackets. This is just 9x squared plus 4. Don't get fooled by addition sign, okay? Hopefully we're okay with that. Very tricky question, but be on your guard. You know to expect it on your assignment. Two brackets, difference of squares. Again, I see some square looking numbers already, 81, 25, 49, 4, 2. So square root of this term. Square root of 49 is 7. Square root of 64 is 8. What is square root of x to the power of 4? Hopefully we'll see that x squared is the square root of x to the power of 4. Why? Because x squared is x to the power of 4. So this is the square root of this, right? So just like, 6 squared is 36. So square root of 36 is 6. X squared is x to the power of 4. So square root of x to the power of 4 is x squared. Let's take this square root of that, 9 over 5y. So 7 over 8x squared, 9 over 5y, plus minus. Doesn't matter which order you put them in. You could put the plus here and the minus here. That's also fine. Let's look at this question. And this is a tricky question because you might think, okay, let me start doing difference of squares here. I'm going to set this up somehow where I have a binomial. There's a subtraction sign. But, okay, hold on a second. What is the square root of 20a squared b? Okay, I don't know the square root of 20. I could write square root of 20. Square root of a squared is a, but I'm just getting a square root of b here. And this is just square root of 500b. And that's not really an answer you want to write. This is not, as hopefully you can kind of intuit, you kind of like know that this is not correct. Because, again, very important, the first step to any factoring is look for common factors. What is common between 20 and 500? Actually, at 20, I can factor out of that entirely. And I also see that I have a b that's common between these two terms. So I'm going to factor that out as well. So what I'm actually left with here is a squared minus 25. And now this looks much more like a difference of squares. I'm just going to leave the 20b outside. Square root of a squared is a. Square root of 25 is 5. A plus 5, a minus 5. This is my final answer. Again, this is fairly straightforward. Two terms, subtraction sign in between them. Square root of 16x to the power of 4. 4x squared. Square root of 1. 1. 4x squared plus 1. 4x squared minus 1. That is my final answer. So hopefully we'll see that this was all fairly straightforward stuff. This is actually one of the easiest lessons to do again. Hopefully we are okay with that. There is a lot of homework. I highly recommend a lot of practice. I guess I apologize for the videos coming out this late, but you still have all of this week, and you will have a significant amount of time next week to kind of go over this again, because we're not going back. You'll not be back in classrooms until at least May. So whenever that is. And again, this is just, I'm going to go over a factoring summary. So here we see that once we start our factoring, the first step is to always look for any common factors that we can factor out first. And then we see, okay, is it a binomial? If it's a binomial, if there's only two terms, does it have a difference in there? If it does, then it's a difference of squares. We know how to factor that. If it's a trinomial, that looks like ax squared plus bx plus c, we know that we have two different. There can be either a simple trinomial, which we did a lot of practice for, or there could be a tricky trinomial where we have a not equal to 1 and you cannot factor anything out. Again, hopefully we have solved the factoring problem right there. So this tricky trinomial should not be, this a term should not be factorable anymore. So here we've again done extensive work on tricky trinomials, and so this is our final step, and we have now completed our factoring. So for homework, I'd like to see question number R and let's see again here. You could give T a try if you're feeling up for the challenge. All these look too easy. This is an easy one, but you can try it just in case you've forgotten how to do questions like that. Try. Okay, so I want you to try B, F, I, N, R, and T. So these are the questions I want you to solve and post the answers in the comments. Post the answers to all these questions in the comment section below with your name. Obviously, hopefully you're trying all of them, but these are the ones I want to see answers for when you when you do your work. So yeah, that we have completed our factoring unit despite pretty much not seeing each other. So that's unfortunate. I miss seeing you guys and going to school and stuff. It was a lot of fun. That unfortunately now has been, I'm just sitting at home doing a lot of nothing. Well, at least I'm making these lessons, so it's a little bit of work. Yeah, well, hopefully we'll see each other at some point when school returns. The current date apparently is set to May, so whenever, if that actually holds up, but we will see each other then. Until then, math must go on. Keep practicing all the work, and we will next week. So we're officially going to start doing school lessons. So we are going to have some kind of lesson. There can be either mandatory face-to-face, so you'll be, mandatory is in, hopefully you guys are okay with like Skyping in or some format. We're getting out, we're still fleshing out or getting what the details are exactly. the process is still not complete. But as soon as that happens, as soon as we know anything, we will obviously share that information with you, and yeah, hopefully we can go forward from there. All right. You have a lot of work. I mean, I don't have to tell you how much practice you can do. There's a lot of practice available, including all like the practice from all the homeworks over here. So you can take a look at all of that. But until then, until we start the next unit, peace out. I will see you or talk to you soon, hopefully. Stay safe, stay healthy. Peace.